What's up? Today we're simplifying radicals with an index larger than 2. What in the world does that mean? So, we're used to dealing with things like square roots that look like that. Well, remember from the first video when we talked about the index, it's the number here in front. So what I mean when I say that we're simplifying radicals with an index larger than 2 is that there's a number out here, 3, 4, 5, whatever it may happen to be, and then we'll be simplifying those. Alright? That being said, and we already know how to simplify square roots, let's just do a couple examples and hopefully you'll get the idea. Alright, so example 1. I am going to take the cubed root of 27x to the 5th. Now if you remember, when we took square roots, we were looking for pairs of things. Well, the larger the index is, the larger number of things that you're looking for. So because this has a root of 3, I'm looking for 3 of a kind instead of pairs. So what I'm going to do is I'm going to break this 27 down, 9 and 3, and 3 and 3. I'm also going to break the x to the 5th down. That's x times x times x times x times x. X to the 5th. 1, 2, 3, 4, 5. And I'm looking for 3 of a kind. Well, the prime factorization of this is all of these 3's all together. So I have 3 3's, which means that I'm going to take out 1 3. The x to the 5th has 5 x's. Inside of those 5 x's, I've got 1, 2, 1 3 of a kind. I don't have 2 3 of a kinds because I have 2 left. I just have the 1 3 of a kind. So I'm going to take 1 x out. Now I've dealt with all that. I can't simplify anything else underneath of there. So I do my cubed root again. I draw my square root or my radical with the 3 right there. And then I'll put the x, because I have 2 x's, x squared, back inside. And that's simplified. Okay, let's look at another example. This one I've got 3xy times the 11th root of 4096 times x to the 15th times y to the 5th times z to the 22nd. Okay. Well, the 3xy I'm going to go ahead and write down because I don't have to do anything with that, and I'm going to use it here in a minute to help me. Now 4096 I'm going to start breaking down. Okay? So I know that because this is an even number that I can divide 4096 by 2. And I get 2048. I'm going to break that down again. And I'm going to get 1024 times 2, which then I'm going to divide by 2 again and get 512, which I'm going to divide by 2 again and get 256. Whoops. 256 times 2, which then I break down again, divide it by 2 again, and I get 128. Those of you that are more familiar with computers might start recognizing some of these numbers. This 128 breaks down into 64. The 64 breaks down into 32. 32 breaks down into 16. 16 breaks down into 8. 8 breaks down into 4. 4 breaks down into 2. Oh, look at all those 2's. Look at all these. Woo! Holy macaroni. How many 2's is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 2's. That means this is 2 to the 12th. Well, how many times does 11 go into 12? That's right, one time. 11 goes into 12 once. So I'm going to be able to pull a 2 out of here, and I'll have 1 2 left over. So I took 11 2's out of here, pulled them out, because I'm looking for a set of 11, and then I had 1 2 left over. That's 2 to the 11th times 2 is the same as 2 to the 12th. Okay? Same idea here with the x to the 15th. How many times does 11 go into 15? That's right, one time. So I could pull 1x out. Okay? If I take 11 x's out of 15, how many x's do I have left? X to the 11th times x to the 4th. That's right, 4 x's. I took 11 out, I've got 4 left. Does 11 come out of 5? No, it does not. So I have y to the 5th. Does 11 come out of 22? Yes. 11 comes out of 22 twice. So that means I'm going to do z squared out here too. I wish this thing would stay in focus. There we go. Alright. That being said, the z's are gone, that's gone, that's gone. I've got 2, x to the 4th, y to the 5th, and that's it underneath. So I've got the square root, or the 11th root of 2 times x to the 4th times y to the 5th. Everything else I've written out here. Let's combine like terms. 2 times 3 is 6. X times x is x squared. Y I've already had out here. Don't confuse that 11 with that y. It's not with the y, it's with the radical. Then I've got z squared. Now I'll do my 11th root of 2x to the 4th, y to the 5th. And that, my dears, is how we do it. I'll talk to you later.